So here's an example of a Mayan numeral on the side, and I just want to remind you about what Mayan numerals mean. Mayans had 3 digits. They had a digit for 0, which is the shell. They had a digit for 1, which looks like a dot. It was a pebble, I believe. And they had a symbol for 5, which was the bar. I should write out that this is 1, and that's 5. So these are the Mayan digits right there. As far as place values go, the places are based on 20. And they increase upward. Whereas ours increase to the left when we write down our numerals. So they increase upward. So this Mayan numeral here has groups. So, and they're groups of 20. So you can't have more than 20 in any particular spot. So down here, I have 5, 10, 15, 16, 17, 18, 19. So there's a 19 in Mayan. Then there's a 0, and then there's a 5. So it looks like I have 3 distinct groups here. So the group down here, these must be my 1s. And then since I'm grouping by 20, my next group should be my 20s right here. And then if I group the 20s by 20, 20 20s is 400. So the next group is my 400s. And then the next group after that, if there was one, there's not here, would be 2400s, which would be the 8000s place for the Mayans. So if I wanted to tell somebody what this numeral here in Mayan meant in base 10, I just expand it. So expanding this into base 10, I have 5 400s, and I have no 20s, and I have 19 1s. Let's see, 5 400s would be 2000 plus nothing plus 19. So this is how the Mayans would have written last year if they knew about the AD calendar. 2019. So this right here again, let's see, highlighter, is the Mayan version of 2019 base 10. So again, to read Mayans numerals, you need to know what their digits meant. So we have the shell, which is nothing, the 1, which is the dot or the pebble, and the 5, which is the stick or the horizontal bar. And they group by 20, so their place values are based on 20. Now there is another version of the Mayan number system where they squeeze in a multiple of 18. And so sometimes you might see instead of 400s here, 20 times 18 is 360, because 360 is close to the number of days in the year. And then they knew there was like a 5-day difference between 360 and the actual number of days. And that was some special 5-day period for them. I can't remember what that was in their history, but they knew there were over 360 days in a year.
Is that the homework seemed to suggest that was the timesing by the 18?
Yeah,
and that's what I found. So.
Yeah, so there's a couple of versions of the Mayan. From what I remember when I read the history of Mayan numerals, when I just go straight by 20s, that was like the commerce number system. And then they had another like scientific number system where instead of multiplying by 20, they multiply by 18 in between. So we've got the alternate Mayan system. It's like their scientific system. / religious. So in the religious one, the first place was the ones, and then they multiply by 20 to get the next place. So the next place up was their 20s, just like we did in the commerce version. But then they multiplied by 18 in this other version of the Mayans. And then, so 18 times 20 gives me 360. So that's the next place in that version of the Mayans. But then after that, they start multiplying by 20 again to get the next grouping. So that would be 7,200, is that right? 2 times 36 is 72, and then 10 times 10 is 100, yeah. So the next place would be the 7200s. So that's a little bit different than this version of it here, where I have my 1s, 20s, 400s, and the next place would be the 8,000s, excuse me. That's a good question. The question is, which version did I put in the homework? So Amanda, you're saying in the homework, I put the version with the scientific version?
Yeah, because I was dumbfounded until I got the 18, and that threw me off because I remember last class you said 20, and I can't remember what exact systems, but
yeah,
that was it.
Make sure I make that clear here. Where's Mayan? Oh, okay. So Mayan numeral system had what is its base? That's okay. I can't remember what video. Is this someone else? Yeah, that's someone else doing that. And then this one, given the Mayan numeral, the equivalent. Okay, so let's test it out. See which version they're using here. I did forget about that catch. So we're going to convert this, numeral. Let's see, show desktop screenshot, please. Let's see which version this is using. So we're going to try and convert this numeral right here. And we'll write it out in a couple of different ways. So first we'll use it using this kind of commerce version of the Mayan number system. So these would be my 1s, and then my 20s, and then my 400s, and then my 8,000s. So if I think this is the interpretation of the Mayan numerals, then I've got 5, 10, 13, 8,000s. And then I have no 400s. And then I have 4 20s. And then I have 1 1. All right, so let's see. Calculator would be nice here. 13 times 8,000. That would be 80 plus 24, which is 104,000. Can someone verify that for me with a calculator? Times 8,000, that is right, thank you. And then we've got 4 20s, which would be 80, and then 1 1. So this would be 104,081 if we're converting with the commerce version of the system. If we're using the other version, let's go check that out. Next page. Convert it using the scientific version of their system. In this case, down at the bottom, we still have our 1s, we still have our 20s, but this would be 3600s. And then this right here would be times 20 of the 7200s. Oops. So then I would have 13 times 7200, which I don't think I'm going to try in my head today, plus no 3600s. Or 360s, excuse me, and then the rest is the same. That would be plus 4 20s and 1 1. So 13 times 7200. There's the big difference here, plus the 81. So that's and I get 93,681. All right, so let's see which version this is asking, and then I'll add a note in there just to be clear. So one version says it's 104.81. And either I screwed it up or that's not it. Otherwise, it is 93,681. Got that right? Yeah. And that is the correct answer. So I need to modify your homework. Let's see if the other ones, looks like they probably do it the same. Okay, so this is problems 10, 11, 12, and 13. Okay, so I'm going to add a note to the homework just to be clear. We're using the scientific version. Scientific. All right, thank you, Amanda. All right, so Mayans, let's see, we did a conversion from Mayan. Let's take a number in our system and see if we can convert it to Mayan. So that's a little harder. And then let's stick with the scientific version. So scientific, oops. Version of Mayan. Let's take next year, the year 2021, base 10, and rewrite it in Mayan using the bases. Let's see, for this one, it would go what? 1s, 20s, 360s, 7200s is the next one. So when we're using the making change version, we need to know what's the largest place we don't need so we know where to start. So we want to know how many 360s are in there, left over for the 20s, and then the 1s. So give this a shot using the first method, the counting change. And then I can show how to do it with the other division method. So remember, to find the remainder, we subtract off the whole number and then multiply back in what we divided. I get a remainder, oops, wrong page, of 221. So that remainder is smaller than 360, so I probably did it right. So then I move on to my next place. How many 20s do I need? So let's see, 20 goes into 22. I could probably do this without a calculator. Once, with 2 left over. 20 goes into 21 once, remainder 1. Checking that on a calculator. 221 divided by 20 goes in 11 times with that decimal remainder. To figure out the whole number remainder, take away the whole number and then multiply by the divisor. So there's my 1 left over. So it goes in 11 times with 1 left over, and that's my 1, so I have this number right now in Mayan. So I have, at the top, there are 5 360s. So let's write it over here. So that's just a bar. For the 20s, I found there were 11. So that would be bar, bar, dot for 11. And they always put the dot above if there were dots, the bars. And then there's just 1 for the bottom. So this says I have 1 360, I have 5, 10, 11 20s, and I have 1 1. So this would be the Mayan numeral in the scientific version for 2021. If I do the long division version, starts off like usual. We would take 20 into 2021. And I'm going to do my short division method on this. 20 goes into 2, no, 20 goes into 20, yes, 1 time. No remainder, so I go to the 2. 20 goes into 2, no, 0 times. 20 goes into 21, 1 time, remainder 1. You can double check that on calculator. I take 20, 21, and divide by 20. I'll see it goes into 101 times with a remainder. To get the remainder as a whole number, we take away the whole number 101 and multiply back the 20. And I get my remainder 1 there. Now, usually we would keep dividing by the same 1, but remember in Mayans, in the scientific version, they first group by 20. That's a multiple of 20. And then right after that, they group by 18. And then they start grouping by 20 again. So in my division, I just did that, divide by 20. Next, I need to do the 18. So now I take 18 into 101. And that I definitely want my calculator for because I'm not up on my 18 table today. So 101 divided by 18 goes in 5 times. So we'll make a note of the 5. Go back and get the remainder. So we take away the 5 we just accounted for, multiply back the 18 that we divided by, and I get 11 as the remainder. And then they group by 20 again after that. So now I divide 20 into 5. 20 goes into 5 0 times with a remainder of 5. And so this is my numeral, 5, 11, and 1. So given the change in the multiples of the bases, I don't know if I like this quicker method here for converting scientific Mayans. I think I like the place value counting back change method better. I don't know about you guys. Curious, what do you think? Counting back change or repeated division for the scientific Mayan? Anybody want to vote? Please make my day and vote. Counting change, like them both. Let's have some other opinions. Ava likes the first one, the counting change. Both. Counting change. Okay, so we got a few more people for the counting change. Yeah, I like seeing a match. It's just I have to always stop and think really hard about when do I throw the 18 in this version here? And I kind of have to look at the chain of events here to remember that. Since it's not something I do every day. I do Mayan once a year when I teach this quarter. So my Mayan is sometimes a little rusty. Okay, so that's Mayan, a little bit of conversion, and I'll have a note here to remind everybody in the homework that the homework questions are using the scientific version of Mayan, which use these slightly different place values. All right, let's take a look at a couple of other ones.